Hi, welcome to my channel pibyme Maths. This is WST02. Here we are solving May-June 2023 Statistics 2 paper. In the previous video, we have covered question number 1 to 4. Let's look at question number 5. A continuous random variable y has cumulative distribution function capital F of x given. Find the values of a and c. So if you observe closely, you have a here, c here, right? This is the lower limit. This is the upper limit 10, right? So we know for lower limit f of 3 will be 0, right? And for upper limit f of 10 will be 1. That's one of the property of the cumulative distribution. So when you sub in 3 here in the place of y and equate it to 0, you will get 1 over 16, 3 square minus 6 times 3 plus a is 0. Bring the 16 to the other side, still 0. 9 minus 18. So minus 9 plus a is 0. A is 9. And then take this condition f of 10 is equal to 1. Replace y by 10 here. So you're going to get 1 over 12 times 100 times 10 is 1000 minus 5 times 10 square plus c is 1. This is 500, 12 goes to the other side, 500 plus c is 12, c is 12 minus 500, minus 488. That's all. Part B, now find the value of b now. Okay, look at the function. B is in here, right? So when you sub in the function, replace y by 5, you will get a function, right? Which will be same as this function when you sub in y 5 here, because both has 5, right? So we are going to sub in 5 here, sub in 5 here and equate these two functions. That's what we are going to do. So when we sub it into the first one, 1 over 16, 5 square minus 6 times 5 plus a is equal to, when you sub in 5 into the second function, 1 over 12, 5 plus b. 1 over 12, 5 plus b. We know the value of a actually, it is 9, right? So take it as 9. Just make b as a subject now. 5 square is 25. 25 minus 30 is minus 5. Plus 9 is 4. 4 over 16 is 1 over 12, 5 plus b. 4 over 16 is 1 over 4, 12 comes here, 12 over 4, 5 plus b is 3, b is equal to 2. b is equal to 3 minus 5 minus 2. That's all, it's just an easy 2 more question. Part C now, find p of 6 to y. 6 is less than y is less than or equal to 9. So we can write it as p of y is less than or equal to 9 minus p of y is less than 6. We know in cumulative this is f of 9, right? Because f of x is p of x is less than or equal to x. That's a cumulative function. Whether there is a equal or not, it doesn't matter because it's a cumulative continuous random variable. So minus f of 6. So we need to calculate f of 9 minus f of 6. To find f of 9, you need to sub in 9 in here. So that's 1 over 12. 100 times 9 minus 5 times 9 square plus c. We got the c as minus 488. Minus 488. Minus f of 6. How do we find f of 6? 6 is between 5 to 9, so sub in here. 1 over 12, 6 plus b. 1 over 12, 6 plus, we calculated b as minus 2, so 6 minus 2. So let's find the value of this. Forget about 1 over 12, that's like a common factor. You get 900 minus 5 times 9 square minus 488. 6 minus 2 is minus 4. You get 3. So 3 over 12 is 1 over 4. That's the answer. For part D, specify the probability density function f of y from 5 to 9. So to find small f of y from 5 to 9, you just need to differentiate this. So you're going to get, when you differentiate with respect to y, 1 over 12 times b. sorry, this question. So it's gonna be f of y is 1 over 12 times b. So b becomes 0, right, when we differentiate? Yes, 1 plus b. So just leave it as 1 over 12 is a function, that's all. Just write 1 over 12, it's just one more question. Part E now. Using this information, find E of 6y minus 5. To find E of 6y minus 5, we take 6y minus 5 and multiply by f of y and integrate it, right? That's how we find E of x, right? X times f of x dx. So since there are 3 intervals, 0 to 5, 3 to 5, 5 to 9, 9 to 10, you need to do that from 3 to 5, 5 to 9, 9 to 10, right? But the 3 to 5 and 9 to 10 is given as 26.5, these two. So you just need to calculate 5 to 9 only, okay? So you can just write this as integral 3 to 5, 6y minus 5 f of y dy plus 5 to 9, 6y minus 5 f of y. From 5 to 9, that's what we calculated here. 1 over 12. 1 over 12 dy plus 9 to 10, 6y minus 5 f of y dy, right? But for these two, we are going to use this value. It's 26.5 plus keep 1 over 12 outside. For this one, you need to integrate it. 6y square over 2, which is 3y square minus 5y, 5 to 9. Calculate this value. So 26.5, 1 over 12 times 3 times 9 square minus 5 times 9 upper limit. 3 times 5 square minus 5 times 5 is lower limit. Calculate this. That's the answer. So I'm going to put everything in my calculator one shot. 26.5 plus 1 over 12. This is, okay, I'm going to open the bracket again. 3 times 9 square minus 5 times 9 close bracket minus, open the bracket, lower limit now. 3 times 5 square minus 25, close the bracket again. 233 over 6 is the answer. That's all. Question number 6 now. Akia selects at random a value from a continuous random variable w which uniformly distributes over a comma b. Okay, so we can draw a little figure. So it should be a to b. A to b. Now the probability that Akia selects a value greater than 17, P of W is greater than 17 is 1 over 5, and the probability he selects a value less than K is 53 over 60. Part A, find the probability that Akia selects a value between 17 and K. Between 17 and K. You can split it and write it as P of W less than K minus P of W is less than 70. W less than K is this 53 over 60 minus. This is W is greater than this, but we need less than, so we put it as 1 minus. Because that's just a complement, right? Complement of W is less than 17, right? Just calculate this. 53 over 60 minus 1 plus 1 over 5. So it's just 1 over 12. Part B, it is known that variance of W is 75. Find the value of A and B and find the value of K. Okay, I'm gonna put the figure here again. Okay, if W follows uniform distribution of A comma B, that's what given here, right? A comma B. So there is a formula for E of x and variance of x, which is given in the data booklet also. The variance of x is b minus a whole square over 12 is 75. So b minus a whole square is 75 times 12 That's 900. So b minus a, take only the positive square root because b is bigger than a. That's equation 1. Okay. Now I'm gonna use the figure now. So this is the figure from A to B. This is A, this is B. In uniform distribution, discrete uniform distribution, we know this value will be 1 over b minus a. So that's going to be the width of this rectangle. Now in part A it says P of W is greater than 17 is 1 over 5, right? P of W is greater than 17 is 1 over 5. So let's say 17 is here. 17 should be definitely between A and B. How do you find this area? That's a rectangle. The base is, the length is b minus 17 times the breadth is 1 over b minus a is 1 over 5. You can write it as b minus 17 over b minus a is 1 over 5. Cross multiply, frame another equation and solve the simultaneous equation. When you cross multiply, 5b minus 50, 35, 85 is b minus a. Move everything this side, you're gonna get 4b plus a is 85. Solve equation 1 and 2, you get the value of a and b. So I'm going to add the equations 1 plus 2. So a will be cancelled. I'll get 5b, 4b plus b. 5b is 30 plus 85, 115. b is 2 5s are 10, remainder 3, remainder 1, 15, 3 5s. So from equation 1, 23 minus a is 30, so a is minus 7. We got the values of a and b already. Now the double I says find the value of k. Double I says find the value of k. This is when we are going to use this info from part A. W is less than k is 53 over 60. P of W is less than k is 53 over 60. Okay, now we know the values of a and b. Put it as minus 7. This is 23. Since it's minus 7, we are going to assume that it's all the way here. Minus 7 and the y-axis is here. This will be 1 over b minus a. 1 over 23 minus of minus 7, 1 over 30. Okay. Now let's say we don't know where the k is. Let's say k is here. P of W is less than k means this area. How do you find this area? K minus of minus 7, that's the length, times 1 over 30 is 53 over 60. Multiply through it by 30, so k plus 7 is 53 over 2. So k is 53 over 2, 53 over 2 minus 7. 39 over 2, keep it as 39 or keep it as a fraction, that's all. Now find minus 5 to 5, the probability between minus 5 to 5. So I'm going to copy the diagram here. This is the diagram now. They want us to find the area from minus 5 to 5, this area. So for C, probability of minus 5 to 5 is, the length of the base is 5 plus 5 times the breadth is same as 1 over 30. That's 1 over 3. D now. Find E of W square. We know this formula, variance of W is E of W square minus E of X whole square, right? Variance of W was given here, right? 75. So 75 is equal to E of W square minus. There is a formula to find E of X for this uniform distribution. It's B plus A over 2. B is 23 plus A over 2. That's E of X whole square. So E of W square is 75. Bring this value here plus this. So it's 75 plus 23 minus 7 is 16 over 2. 16 over 2 is 8 square is 64. 139 is the answer. This formula B plus A over 2 for E of X is also given in the data booklet. Question number 7 now. The last question. A bakery sells muffins individually at an average rate of 8 muffins per hour. Okay. Find the probability that in randomly selected 1 hour period. So this also per hour, this also 1 hour. So we can take it as lambda is equal to 8 and x follows Pearson distribution of 8. So they want us to find the probability that the bakery sells at least 4, not more than 8. So not more than 8, at least 4. So it should be bigger than 4, 4 or bigger than 4, less than or equal to 8. We need to find this probability, which is same as P of x is less than or equal to 8 minus we need 4. So we subtract till 3. So I'm going to take the table values for lambda is equal to 8 and x is 8 and 3. Lambda is 8, that's here, x is 8 is 5925, 0.5925 minus x is 3, for 8, 1, 2, 3, 0.0424, 0.0424. So 0.5925 minus 0.0424. 0.5501. Just leave it as it is. Let's move on to part B now. A sample of 5 non-overlapping half-hour periods is selected. So here in this question it says 8 muffins per hour. So for half an hour it's going to be 4 muffins, right? So lambda might be 4 here. Okay. And then find the probability that the bakery sells fewer than 3. Find the probability that the bakery sells fewer than 3 in exactly 2 of this period. We need to find 5C. What is the probability of success here? Selling fewer than 3 muffins. So we are going to take it as y follows Pearson distribution of 4. And first we need to find y is fewer than 3, which is same as y is less than or equal to 2. So I'm going to use the table value for lambda is equal to 4, x is equal to 2. So lambda is 4, x is equal to 2 is 2381. 0.2381. That's the probability of success here. We know n is equal to 5. Probability of success is 0.2381. So it's m follows binomial distribution of 5, 0.2381. Why binomial distribution? Because we are finding 2 out of 5, right? That's how they'll combine this binomial and Pearson. So they want you to find exactly 2. So P of m is equal to 2 is, the formula is 5C2 times P to the power 2 times Q. Q is 1 minus P actually. 1 minus 0.2381 to the power of 5 minus 2. So let's calculate this. 5C2, 5 times 4 by 2, 10 times 0.2381 to the power 2 times 1 minus this, which is 0.7619 to the power 3. And you get this value 25073, 0.25073 round it to 3 significant figure. That's all. Question number C. Part C now. Given that 4 muffins were sold in 1 hour period, that's a condition. Find the probability of something. Looks like a conditional probability. Okay, find the probability that more muffins were sold in the first 15 minutes than in the last 45 minutes. Okay, that's a little trickier question. We need to understand it first. This is a 60-minute period. This is first 15 minutes and 45 minutes. In 1 hour period, okay, what's a lambda? 8 muffins per hour, right? Okay, so lambda is 8 muffins per hour. Okay, in 1 hour period they sold only 4. Okay, but we need to find the probability that out of this 4, more muffins were sold in first 15 minutes than in the last 45 minutes. What does that mean? That means out of 4, let's say they sold 1 here, 3 here, you cannot take, because they must have sold more muffins in the first 15 minutes. 2, 2, you cannot take that. If it's 3, 2, Yes, they sold more muffins in the first 15 minutes. You can take this. 40, you can take this also. So that's what they are saying. Okay, so we can solve this question by using two different methods. I'm going to show you both the methods now. First of all, we can write, let's say A is the number of muffins sold in first 15 minutes. B is the number of muffins sold in last 45 minutes. They want us to find the probability of A is bigger than B, but the condition is they sold 4 muffins in 1 hour period. Okay, here the variable is X, right? So X is equal to 4. This is what they want you to find out. So apply the formula for conditional probability. You need to put P of X is equal to 4 in the denominator, intersection of these two. That means 4 muffins sold, but they sold more muffins in the first 15 minutes period. That means this P of A is equal to 3 and B is equal to 2 plus P of this A is 4 and B is 0. They want us to find this probability. To find the probabilities for this one 15-minute period, what is the lambda? The lambda is 8. There are 8 muffins sold per hour, but they sold only 4. Doesn't matter. For the first 15 minutes, this is per hour, right? So when you divide by 4, you're going to get 2 here. So for this one, when you find the probability, you need to take it as lambda is equal to 2. How about for 45 minutes? Lambda is equal to 6, right? So the probability of A is equal to 3 is e power minus lambda, or lambda power 3 over 3 factorial times. B is 2. Sorry, 3 and 1, right? Total is 4, not 3 and 2, 3 and 1. B is 1, so e power minus lambda 6 power 1 by 1 factorial plus. A is 4, e power minus lambda is 2 power 4 by 4 factorial times. B is 0, so e power minus lambda power 0 by 0 factorial. Everything divided by X is equal to 4. Here you need to use lambda is equal to 8 actually, because they sold 4 muffins in 1 hour period. For 1 hour period, lambda is 8. So e power minus lambda power 4 over 4 factorial. Sorry, power minus 8. Lambda is 8, right? We can calculate this. That's one method. So you can take e power minus 8 as a common factor and cancel. So if you combine these two, it's e power minus 8, right? Take out and cancel with the denominator. You get 2 cube over 3 factorial times 6 power 1 by 6 factorial plus 2 power 4 by 4 factorial times 6 power 0, everything is 1, divided by 8 power 4 by 4 factorial. Let's calculate this now. This is basically 8, right? 8 plus 16 over 4 factorial. That's 26 over, sorry, that's what? 26 over 3 divided by, denominator now, 8 to the power 4 divided by 4 factorial. 512 over 3. 3 can be cancelled. You'll get 13 over, okay, 26 over 512. 26 over 512. 13 over 256. That's one of the way to find the probability. We can use binomial distribution to find the probability also. So I'm going to show you the method 2 now. So we got the answer already here. So now I'm going to show you another method now. Now there is 15 minutes and 45 minutes, right? So if you put it as a ratio, it's 1:3. So probability of the muffins sold in first 15 minutes is 1 over the total ratio. For 45 minutes, 3 over the total ratio, right? Okay, now the N is 4 muffins were sold. So x follows binomial distribution of 4, 1 over 4, let's say. What is x? The number of muffins sold in the first 15 minutes. So you can write this. X is number of muffins sold in the first 15 minutes. So if x is the number of muffins sold in the first 15 minutes, this will be 4 minus x, right? So definitely x is greater than 4 minus x. So you put it this side, 2x is greater than 4, x is greater than 2. They want us to calculate p of x is greater than 2, right? So x is greater than 2. X is the number of muffins sold in first 15 minutes. Greater than 2 means it can be x is equal to 3 plus x is equal to 4. We need to find these two probabilities now. So n is 4, it's 4C3. Probability of success power 4 power 3. 3 failure power 4 minus 3. That's a formula, right? 4C4. 1 over 4 power 4 and then 3 over 4 power 4 minus 4. You get this answer, you calculate this, you will get the same answer. So let's try calculate this and see what's happening. 4C3 is just 4. 4C3 is just 4. So 4 times 1 over 4 to the power 3 times 3 over 4 to the power 1. 6 over 3 over 64 plus. Okay. 4C4. That's 1. 1 over 4 to the power 4. 1 over 256. So 1 over 256 plus 3 over 64. You got the same answer, 13 over 256, which is the same answer we got. So there are two methods. Whichever method you are convenient with, you can apply the method. That's all.